Okay, in this video we're going to talk about displacement and distance and how they're different. So displacement is a vector quantity and it's defined as the change in position of an object. So that's the total change from beginning to end. Distance, however, is a scalar quantity defined as the sum of all the changes in position. So because displacement is a vector, it'll have both magnitude and direction. And because distance is a scalar, it'll have only direction, or only magnitude. Okay? So, if I have displacement, I know how far something was moved and where it was moved to. If I have distance, I know how far something was moved, but I don't know where it might have been moved to. It could be any direction. So let's take this example. So imagine that you and your friend, you being the green dot and your friend being the red dot, want to go to the same place in town. And so each of these squares represents a city block. And you say, I know exactly how to get there, and your friend says, I want to do it myself and decide how I'll get there on my own. And so you both start your journey. So you, the green dot, you travel, let's see, 1, 2, 3, 4 blocks west. Whereas your friend, the red dot, travels 1 block north. So he travels 1 block north. He travels 2 blocks west. Then 1 block north, then 2 blocks west, and finally 2 blocks south. So all in all, your friend walked 1, 3, 4, 6, 8 blocks total when you sum together his distances. So he would have walked a distance of 8 blocks. And you would have walked a distance of 4 blocks. However, even though your friend's distance was 8 blocks, and you only walked 4 blocks to the west, your displacement and your friend's displacement is the same. Both green and red dots displacement is the same because you both start at the same location and you both finish at the same location, so you both have the same displacement. So your displacement for both you and the green dot is 4 blocks west. Okay. So let's look at this in a little bit different manner. So let's do another city problem. So for this city problem, let's assume that each block has a side that is 20 meters long. So each side of each city block is 20 meters long. And you walk 1, 2 blocks north, and then 1, 2, 3 blocks west. So you would be walking, so if this is 20 meters each, 20, 40 meters, and 1 meter, 20 meters, 30, 40 meters, and then 60 meters. So just like this triangle shown down here. So what would your total distance be? Total distance walked. Well, remember, the distance you walk is just the sum of all the paths you took. So I would just take the 40 path, 40 meters, and I would add it to the 60 meter path, and I would find that your total distance walked was 100 meters. What about your displacement? Well, remember that your displacement is just the length from where you start to where you finish. So we need to find the hypotenuse of this right triangle, or the resultant of these two components of your displacement. So let's see. We can do that by using Pythagoras' theorem. A squared plus b squared square rooted should equal the length of our hypotenuse, c. So if I square 40 meters squared plus 60 meters squared, I should be able, and then take the square root, I find that my hypotenuse was 72 meters long. My displacement is 72 meters. Good. Okay. Now, because this is displacement, I need both magnitude, 72 meters, and I need a direction. So in order to find the direction, we can use our trigonometric functions. So I'm going to use a tan function because I have the opposite and I have the adjacent side lengths given to me by the problem. Okay, so tan of the angle I'm trying to find is equal to opposite over adjacent. So I can see that tan theta is going to be, the opposite is 60 meters and the adjacent is 40 meters. And so then I need to take an inverse tan function to solve for my angle over 60. And I find that the angle of my displacement is 56 degrees. Okay? And so this is 56 degrees. So I would say that this is 56 degrees. So if this is north, south, east, and west, and we're walking 56 degrees this direction, I would say that this is 56 degrees north of west. Okay. That's it for displacement.